When you set up anything in production and if you want good result from it, you need to be aware about nitty-gritties. I mean to say creating an S3 bucket is simple, but how do we manage S3 bucket effectively is what is something you need to know, specifically as a developer, because you will have limited access to the assets and you have to manage your use cases using those limited assets, right? So this is as of now, AWS has 25 regions, 81 availability zones, 11 local zones, wavelet zones will come later. It is specifically used for ultra low latency application, then 7 announced regions, 6 announced local zone, 2x more region, 245 countries, 18 direct connect locations. You'll come to know what is direct connect also, and 230 plus point of presence. So AWS is the most experienced cloud today. Most of the cloud providers actually are driving their innovation in direction of AWS, and AWS is far, far, far ahead as compared to others. Now, this is something which we need to understand. When you develop or when you define architecture, there are certain key, essential principles that you need to follow. You need to always design solutions which are scalable. So AWS, follows mechanism or principle of ensuring that whatever services they are providing, they are scalable. Now it is up to you. You want manual scalability with manual intervention, or you want automated scalability. For automated scalability, you will be getting configurations that you can do. For example, you can scale up your instances. You can set up auto scale configuration so that your instances automatically scales up depending on the identified metrics. For example, it can be CPU usage or it can be various other metrics. Then AWS also follows principle of disposable resources. I mean to say that I will be using it till I need it. After that, I should be able to dispose it off. Disposing off means you are deallocating resources that actually you are using. It directly impacts the cost. AWS is designed keeping in mind automation, and that's the reason you can automate your infrastructural as well as other use cases using third-party automation tools also, which can be Ansible, Terraform, and various others. Not only that, you can write plain Python script as well, or Java in order to automate tasks, right? Apart from that, AWS has its own proprietary infrastructure provisioning automation called as CloudFormation, and they provide you SDK using which you can write automation supported by multiple different languages. See, loose coupling is something which we have been learning from day one, right? I mean to say, if coupling is less, your applications components are independent. And our objective is always to achieve minimum coupling and maximum strength, right? So your objective should also be to decrease coupling. And that's what AWS says. And this is the reason why services are decoupled from each other. So that in case if one service is not available, impact is not there on your overall architecture. AWS says that talk in terms of services, not servers. For every service that AWS provides, you will have an endpoint. So you will not talk in terms of servers. You will say services, right, which are available to you using some endpoint. AWS supports diverse databases, whether it is PostgreSQL, MySQL, Oracle, MS SQL Server. All those are provided by AWS by facilitating one single service called as RDS, Relational Database Service. Manages increasing volume of data. I mean to say, initially you have allocated some storage in form of volume. Now you can tell AWS, or AWS says, see, I can grow as your data grows. You don't need to worry, right? So you will be charged only if there is data. Removing single point of failures. So when you architect your AWS or any cloud or any architecture, your objective should always be to ensure that there is no single point of failures. And that's the reason why AWS comes with multi-regions, multiple availability zones, edge locations, and others. Optimized for cost. AWS always prefers that their customers should go and first estimate what services they are going to use and then decide, right? So it provides you optimization for cost also by providing help to configure, whatever minimum possible assets are required to run your IT transformation or businesses that are transformed in IT smoothly. Caching, we have seen, it provides caching because caching is something which helps to, eliminate frequent access to the direct servers. And security. There is a concept called a shared responsibility, and security is driven by shared responsibility principle. AWS says that whatever asset I am creating, I will ensure that it is secure. But whatever you are deploying, I'm not going to take responsibility of that. It is you who is going to define security layer for it. So if I am selecting infrastructure as a service, AWS facilitates me to, secure it, or it comes with automated security. If you are installing platform, it is your responsibility to secure it, not AWS responsibility, right? But AWS provides sufficient services in order to secure end-to-end application provisioning and serving to the end user. So these are the principles. So now if you are planning to design architecture or to write application, you need to always keep in mind that I'm writing application for cloud. So how my application will behave when it is scalable. Just an example, stateful and stateless, right? Now, in case of stateful applications, state need to be managed, right? Or it need to be stored. So whenever second request comes, it has to be served by the same thread because it's the same thread which has the session data. So you need to have proper plan. How do you scale in those scenarios? Always try to adopt disposable resource paradigm of utilizing resources. Try to automate because when you write script, you will test script. Manual interventions will be reduced. So keep all these design principles in mind, whether you are architecting or you are developing applications. So these are some of the essential design patterns that actually you need to follow. There is huge list of best practices. So I have already kept the URL here. You can go through it for more details on this. But best practices suggested by AWS indicates that always go with decoupled components, think parallel processing, design for failures, and implement elasticity. What is elasticity? Elasticity is my resources should grow and shrink as per the need. I mean, it should not be always, scaling up. It should also be scaling down. And that's what is elasticity, scaling up, scaling down as per the requirement. So these are some of the best practices that we can follow in terms of cloud architecture.